All right, ladies and gentlemen, today we're going to talk about the sine and the cosine functions. So we're going to graph and analyze the functions. Sine when theta is mapped to the sine of theta, and cosine when theta is mapped to the cosine of theta. So first off, without using a calculator, you're just doing your divisions here to figure out what these are approximately. This one here is exactly 2 because the 2 and the radical are inverses. The square and the radical are inverses. Next up is that this one here is approximately 0.866. This one is approximately 0.707. And this one is approximately 0.577. These are going to show up a lot, so you might want to just remember these ones. It's going to help us out later. Okay, so we're going to explore the shape of the function. We want to know what the sine function looks like. Like we know linear looks like this, and we know that parabolas or quadratics look like this. So it turns out the sine function looks like that, and we want to see why it does that. All right, so complete the table here, and then we're going to start plotting the points down here. Notice that the first 5 points are already done for us, and we're going to keep going. All right, so let's see where we left off here. After we look at our degrees and we notice that there is a pattern. No, it's what's called a chiastic structure. When you study literature, chiastic structure has to do with certain topics. You know, somebody is happy, something happens, boom. Then the other stuff happens in backwards order, and then they're happy again. So we see that chiastic structure all over literature, and we'll see it even here. So notice it goes up the ladder to 1 and back down that same ladder. Notice the 0.866, the 0.707, the 0.505, and then it repeats itself down here, but in the negative way. So that took us quite a while to graph, and after we make our smooth curve through the points, we get this sinusoidal shape. So back in the day, way back in the day, when you graphed a quadratic, you called this puppy a parabola. So now we would say a parabolic shape. Well, same thing here. A sine curve yields us sinusoidal shape. Well, a cosine, turns out a cosine will do the same, except instead of calling it a cosinusoidal, we still call it sinusoidal. So this is our beautifulness right here. Take a picture of this, post it on your Instagram account. Hashtag math is awesome. Now what we can do, of course, is graph by checking. Check by graphing. Sorry. And your graph will yield you an answer the same as what you just got. Okay, so based on the graph in the table, we're going to see that the sine function is positive when? Well, it's positive between 0 degrees and 180 degrees. Remember, that means 0 radians all the way to pi radians. Remember, the sine is the y value on the unit circle. So in my unit circle, it's positive here, and it's negative here. So when is it negative? Between 180, of course not including 180, although there is an included there because of 0 is not positive. And x is all the way up to 360, and as radians, we get from pi to 2 pi. Of course, the next question we ask after doing all that work is, like a true mathematician, we ask ourselves, how can a bear graph the sine function quickly? Good question, says Penny the Woo. Trademark, hashtag, I won't be sued for this. Okay, so what do we notice about the sine function? The sine function. If we want to talk about where it starts, kind of like where it begins, which it doesn't, of course, but like if you're just going to quickly draw it, it's going to pass through passes through the origin, which is also known as 0, 0. And that's called the origin. So that's where we can, quote unquote, start. Next, its first maximum. When do we get to the maximum? So if we're down here, we can kind of put a point there at 0, 0. So the first max is at 90 degrees, also known as pi over 2. So at pi over 2, it gets all the way up to 1. Next, we can do x-intercepts, and we can just do them in terms of intervals. So an x-intercept happens every 180 degrees, also known as every pi. So here's a pi, here's 2 pi, here's 3 pi, and it actually works going in the negative direction as well. Next, our first minimum occurs, so our trough goes here, comes down, and notice it's going to be right there at 3 pi over 2. And 3 pi over 2 is the same as 270 degrees, and it drops down. Notice that the lowest it gets is negative 1. So notice my pattern here. Every halfway mark, pi over 2, every pi over 2, we get a high or a low, like so. We're going to rinse and repeat, and all you have to do is make that curve fit. Make that curve fit. So try to, without making straight lines, trying to make that curve fit, passing through all these points to the best of your ability. And notice I'll repeat the other end there. So we walk through this one together. Down below, just practice that again, following those same steps. Just so that you have a perspective, one cycle is this right here, just all 360 degrees. That's called a cycle for your sine function. That's called a cycle. Now, the next and last thing we're going to look at is how cosine is related. Remember that the complements theorem states that whenever you take the complement of theta here, that's the same as sine of theta. And if you have sine of the complement, that's the same as cosine. What does that mean mathematically? All right, I do want to point out that the complements theorem says this, that as I take the complement, whoa, watch this, whoa. I'm taking my cosine and I'm just sliding it a little bit, but watch this. My cosine suddenly becomes the sine. Now it's its own thing and then becomes sine again. Boom. So they just go back and forth, just becoming their independent of each other, but then they become each other too. So that's the idea of complements theorem. So just to refresh, this one is saying pi over 2 minus theta, and the same goes here for the sine function in radians. Thus, we see that the sine function is simply the cosine function shifted. And that's an F.
I missed it.
If it was a,
If
it was a T, it would not be so good. Hashtag holy shifted. All right. So what about this here? When we're thinking about the cosine function,
That's not because it's digital.
so
I don't think the definition needs to be that's physical.
how do we walk through this fast? How do we graph this without doing the whole thing? Well, the first thing to note, with the sine we started high, and this one, with the sine we started in the middle, this one we start high. It passes through 0, 1. So it starts up instead of in the middle. When I say middle, I mean 0. I don't want to start low. Neither of the functions start low per se, not unless you're shifting in some sort.
Do it like Carl.
So it starts high, and that's my first max. My x-intercept is going to, instead of coming here and then coming down at pi, it's already going down. So every pi over 2, again 90 degrees, that is where we get on the halves. On the halves is where we get our x-intercepts. So our first minimum occurs at pi all the way down there. And of course, the maxes happen every so often, and the mins happen every so often,
This is fun.
and we graph them.
What's better than some wavy lines?
I'm glad you said that, Chad. I'm
Wavy
saying the exact
lines.
same thing.
Wavy,
Wow. Look at that. And keep going. Whoopsie, I forgot my...
remember, this isn't a competition, but Mr. Swenson's lines will break your line backs.
And let's finish this puppy up.
Yeah, I know.
Boom. Now I want you to practice ultraves down there, just getting this right. The ultimate question you're going to ask yourself is, how do you know what to do, where to do? So I have no clue. I was trying to play with this the other day, seeing if I can come up with a nice way to remember. So if I did sine like this, and I did, there's my I, and notice I just made the N go like that. You see what I did there? You see the sine there? And then I tried to do the same thing with cosine. It was a little bit different, but cosine, I said the cosine goes more like high, like that, because the C goes there, the O goes there, and the S goes there. I have no clue if that will help you, but if it does help you, see that? Great. Or you just remember this one right there, that the sine goes to the origin, then the other one is just shifted up. So again, whatever it takes for you to remember, just like we did with unit circle, find the thing that makes sense to you.